We are going to talk about the difference between potential and kinetic energy. These are two types of energy that are very different from each other but very closely related. All objects have these two types of energy. So what you need to know, what's the difference between potential and kinetic energy? What are common examples of each type of energy? And then hopefully you'll be able to label each type of energy on a diagram or on a picture. First of all, energy is the ability to do work. If you have a lot of energy, you're able to do a lot of work. And I'm not just talking about a person. If you have a lot of gasoline in the lawnmower, you're able to mow a lot of lawn. And if you have a lot of acid inside a battery, you're able to get a lot more work done with whatever you're using the battery for, like a flashlight. Potential energy, this is energy an object has due to its position. A potential and position start with the same sound. That's how I remember them. Potential energy comes from pulling an object back or lifting an object up. An example of potential energy I like to use a lot in class is Angry Birds. When you're playing Angry Birds on a phone or computer and you draw the Angry Bird back as far as you can with your finger in the slingshot, you're giving it a lot of potential energy. You've probably had one of those mishaps where you accidentally bump the screen and you don't pull it back far enough, the Angry Bird doesn't go as far. Kinetic energy. This energy is energy an object has because of its motion. So back to the Angry Bird idea. As soon as you release the Angry Bird from the slingshot and it flies across the screen, that Angry Bird has kinetic energy. So let's see if you get the idea here. Which picture shows balloons with high kinetic energy? On the left you've got a whole bunch of balloons that are deflated, and on the right you have a whole bunch of balloons that are inflated. The answer is the balloons on the right. The balloons on the right are in motion. They are floating, they are moving, and the balloons on the left, they're not. However, the balloons on the left have a lot of potential energy because they have the ability to one day be just like the balloons on the right. This is a diagram that a lot of teachers like to use when we teach about kinetic and potential energy. Roller coaster. So at letter W, does the roller coaster car have high potential energy or high kinetic energy? The answer is potential. Now, I understand the confusion a lot of kids have because the roller coaster car is always moving forward, but at this point, at point W, the roller coaster car is not moving up, and it's not moving down, and it's getting into a position where that's going to change. That is why the car has potential energy. At point X, does the roller coaster car have high potential energy or high kinetic energy? Yes, at point X, the coaster car will have really high kinetic energy, and that's because it's been moving so fast. It's gone down the hill, gravity's pulled on it, it's reached its maximum speed, so therefore it'll have a lot of kinetic energy at X. So you might have noticed, or it may have occurred to you, that energy can be converted from potential to kinetic and then back again. So with the roller coaster example, you've got high potential energy on the car when it's at the very tallest peak. Then you've got high kinetic energy when it reaches the bottom of that first hill. The next hill on a roller coaster is always smaller than the first one. So there you've got medium potential energy. And that's the reason why roller coaster designers will put the tallest hill as the very first hill. It's so that all of the energy that the car needs for the entire ride will be built up in that first section of the roller coaster. So when Katniss from Hunger Games is aiming her arrow at a deer, what kind of energy does the arrow have? Hopefully you guessed potential energy. What she's doing, now she might be moving the bow a little bit, but what she's doing with the arrow is she's putting it, excuse me, she's putting it into a position where the arrow is going to be able to fly very fast and very straight. Teachers also like to use diagrams like this one on tests. So you may even see this. You've got a cannon shooting a cannonball in this diagram. Other teachers will use pictures of someone shooting a basketball, or somebody throwing a baseball, or you can think about it like the Angry Bird flying across the screen on your phone. They all follow a similar motion path. So us teachers, we like to give pictures like this and then ask questions like, at which point does the cannonball have the most potential energy? The answer would be C. That is the point where the cannonball is at its highest. It's not moving up, it's not moving down. It's getting ready to start its descent and speed back up again. And I had a student the other day in class say, wouldn't the most potential energy be at point A? The only problem with that is at point A, you're not looking at the cannonball inside the cannon. You're looking at it as it has come out of the cannon. So it's already started moving. And that would give it a lot of kinetic energy. Still some potential energy, but heavier on the kinetic energy side. You might also see something like a pendulum on the test. This is something that will move back and forth. So it'll move from point A to point E, and then back to A, and then back to E. So this is what you see at the base of a grandfather clock. It helps keep time. Metronomes are like upside down pendulums. When somebody is hypnotizing another person on an old cheesy movie, they're using their stopwatch like a pendulum. When you're on a swing on a playground, that's a pendulum. So the idea is that if we show you a diagram like this and we ask you, okay, at point A, does this object have a lot of potential or a lot of kinetic energy? Hopefully you'll be able to say potential because it has slowed down and it's getting ready to move back to E. When it gets to E, it's got a lot of potential again, and then everywhere in between is kinetic energy. This is a Newton's cradle. It's kind of like a toy for nerds. Okay, not all nerds, but okay, I'm a nerd. I like it. Anyway, this is a Newton's cradle, and the way it works is you lift up the steel ball at one end to give it a whole bunch of potential energy. As soon as you release it, the kinetic energy that it has gets pushed through all the other balls and then hits the one on the very farthest end, giving it kinetic energy until it reaches a point where it has only potential energy. Then that far ball on the left will recycle the motion and move the other way, and it will have kinetic energy, hit all the balls in a row, move through to the one on the end, where it will end up with a whole bunch of potential energy, and this will go back and forth and back and forth.
This is the second part of the video. You are going to be writing in vocabulary for 5 different words. If you're not for sure what page number you're working on, look in your planner or check eChalk. Go ahead and title the page Physics Vocabulary Review. Divide up your paper so that you can put in 5 different vocabulary words, their definition, and draw a little picture to go with it. These words are review from the video and review from 6th and 7th grade. You should be very familiar with kinetic energy, potential energy. We're going to start to talk about energy transformations in our next homework assignment. And we also need to know what maximum and minimum means, because we're going to be talking about maximum and minimum potential energy. Once you complete the notes, you have finished this section of the homework. Good job.